Hello friends, this video is for class 10 students who are going to appear HSLC exam. As you know, this year the pattern of the paper will be changed, so you will get MCQs 50% or any other 1 marks questions. Okay, now first let us discuss the first chapter, real number. We are going to discuss those important topics on which MCQs may be asked, and we are going to solve some previous year's MCQs which are already asked in HSLC. Okay, so this is chapter 1, real number. Okay, so before we start, please subscribe the channel if you are new to my channel and share with your friends, and also hit the bell icon so that you get notified when new video will be uploaded. So let's continue. So here you can see the first important topic is our Euclid's division lemma. So here it says that for any two integers, suppose you have any two integers a and b, then there exists two unique integers q and r satisfying this condition. Okay, this condition means you can say this is division algorithm. Okay, so you can so here a can be regarded as dividend, b can be regarded as divisor, and q is quotient, and r is the remainder. So it is division algorithm. So question may be asked on this topic this way: for any two integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where so these are the four options. Which one is correct? We need to find that one. So here you see, if you read the Euclid's division lemma, here we have got this condition: r is greater than equal to 0 less than b. So here the option C is correct. Answer C, right? Or the same question can be asked in this way also. According to Euclid's division lemma, given positive integers a and b, there exist unique integers q and r such that, so here this condition is correct in all options. This division algorithm, a is equal to bq plus r. So we have to check this condition: r is greater than equal to 0 less than b. So here you see the third option is correct. So this is the answer, right? This question was asked in HSLC 2016. So hope you have understood. Now let's move on to next topic. Next we have rational number and irrational number. So a number is said to be rational if it can be written in the form of p by q, where q and p and q belongs to z. Z means set of integers, set of all integers. That means z is equal to 0 1 2 3 dot 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 so on, and here -1 -2 and so on. This is integer. This is the set of integers, right? So rational numbers are those which can be written in this form. Suppose you have a number 2. 2 is a rational number because 2 can be written as 2 by 1. 3 is rational number. 3 can be written as 3 by 1. 0.5, which can be written as 1 by 2. That is also rational. So hope you have understood this. Now let us discuss about irrational number. Those numbers which cannot be written in this form, p by q form, right? So those are irrational number. So what type of numbers cannot be written in this form, p by q form? Those numbers whose decimal expansions are non-terminating and non-repeating. Okay, so those type of numbers, let me explain. Those numbers whose decimal expansions are non-terminating and non-recurring, or you can say non-repeating and non-repeating, right? Okay, now remember one more important thing. So remember, pi is irrational number. irrational number. The most important thing you must know, if under root you have a prime number, then it always gonna be irrational. Remember this concept, it's gonna help you a lot. Okay, if under root, if you have a prime number, then this is always gonna be a irrational number. Let me give you an example. Suppose you have root 2, right? So you have root 2 is a prime number. If you have root over 2, then it is irrational. If you have suppose root 8, now 8 is not prime, but if you factorize 8, you will get 4 into 2, and square root of 4 is 2. That's why root over 8 can be written as 2 root 2. Again, here 2 is prime number, so here we have root over 2, so that's why 8 is also irrational. Remember that way. Okay, so that means we can say that let me arrange it again. Just wait. That means you can say that if you have a number which is not perfect square under root, okay, not perfect square, then it's gonna be irrational. Suppose you have root 6 is not perfect square, so it is also irrational. Because if you want to if you try to find the square root of 6, then you will get non-terminating, non-repeating decimal expansion. That is why if you have root over a number which is not perfect square, then it's gonna be irrational. Remember those things. So now let us discuss some questions based on these topics. So here is the first question. So root 7 is an integer, rational number, prime number, and irrational number. Which one is correct? So root 7 is prime, right? So I have already told you, if you have prime number under root, then it's going to be always irrational. So our answer is D. It is irrational, right? This question was asked in 2015, HSLC 2015, right? Remember that. Now, which of the following is a rational number? So here we need to check which of these 4 options is rational. So here root 2 by root 3. So root 2 is irrational, and root 3 is also irrational. So that's why as a whole this number is irrational. So we know that root 2 is irrational, pi is also irrational. That's why this number is also irrational. Then again, root 5 is irrational, root 6 is irrational, and that is why it is also irrational, right? Now here you can see root 3, it is irrational, that's okay. Root 27 is also irrational, but the result of this is not irrational. Let me tell you why. Here you see root 3 is root 3, root 27, it can be written as 3 root 3, right? Let me tell you how. Root 27, if you factorize it, you will get 3 cross 3 cross 3. That means 3 into 3 into 3. Then 3 into 3, its square root will be 3. So you will get 3 into root 3. Correct? So here root 3 cancels. You will get 1 by 3, which is a rational number. This is a rational number, right? So that is why option D is correct. So hope you have understood this. Now let's solve another question. And remember, this one also asked in 2018 HSLC 2018. So now let's go to next question. the smallest number by which root 27 be multiplied so as to get a rational number. Here you see, as root 27 can be written as root over 3 into 3 into 3. So here you see the factors are unpaired, right? To make it perfect square, we need root 3 root 3 root 3 into 3. That means we need one more 3 to make it perfect square, right? Then it's gonna be rational, right? So which can be written as root 3 into root 3 into root 3 into root 3. That means you see, if you multiply these this first three root 3's, then you will get root 27, right? That means with root 27, if you multiply this root 3, then you will get 3 into 3, that's gonna be 9, right? That is rational number. So our correct option is root 3. So hope you have understood this, right? So now you see, with root 27, if you multiply root 27, then also you will get a rational result. But root 20 here it is given the smallest number by which root 27 must be multiplied. So here you see, out of these 4 options, root 3 is the smallest. That's why that's gonna be the correct answer. So hope you have understood these things. So now let's go to next. Now let us discuss the next topic, that is decimal expansion of a rational number. Suppose you have a rational number. So rational number can be written in this form, p by q, where p and q are integers. P, q belongs to z. Z represents set of all integers. That means 0, 1, 2, so on, and -1, -2, ... right? And q should not be equal to 0, right? Here q should not be equal to 0. If q is 0, that means denominator is 0, then this is going to be not defined. Now you see, if q can be expressed, if the factorization of q consists only 2's and 5's only, 2 to the power n into 5 to the power m, where n and m, these are nothing but 0, 1, 2 and so on, right? 0, 1, 2, 3, so on, right? So then the decimal expansion will be terminating. Otherwise, that means if q cannot be expressed in this form, then otherwise non-terminating and repeating, right? Now let me give you examples. Suppose you have 3 by 50. So 3 by 50 can be written as 2 to the power 1 into 5 to the power 2. 5 to the power 2 is 25, 25 to the 50, right? So here you see in the denominator we have 2's and 5's only. So if you find the decimal expansion, so 3 by 50, if you divide 3 by 50, then what you will get? 30 is still not divisible. 300, then 6 times, then it's going to be 300. So here we are getting remainder equal to 0. So this is equal to 0.06. So this is terminating. That means you are getting remainder 0, right? Suppose, let me take another example. Suppose you have 2 by 15. So 2 by 15 is here you see 15 can be written as 3 into 5. Here we have 3 and 5, right? 3 and 5. So this is gonna be non-terminating, repeating. Let me show you how. So if you divide 2 by 15, then it's gonna be 0. If you give decimal here, 15 ones are 15, then 5 comes down 0. 5 3s are not 3. Again 15 ones are not 15, 15 threes are here. You see, if you give 3 times, that's going to be 45, then again 5, again 0, again it's going to be 3, again 45, then again it's going to be remainder going to be 5, and it will be continued so on. So that is why it's going to be 0.1333 so on. That means 0.13 recurring. That means recurring means it is repeating. Okay, this is non-terminating. That means we are not getting the remainder 0, and it is repeating, right? So again, one more thing that you should know. Suppose you have a number 3 by 15. So this is terminating. Let me tell you why. Though you see 3 by 15, 15 here, you can write this 15 as 3 into 5. Now you see this 3 can cancel this 3 on numerator, so it's going to be 1 by 5. So we are getting 5 only. Then it is terminating. If you divide 1 by 5, then you should get 0.2, right? It will be terminating. That means you can say, if the denominator, the prime factorization of the denominator, if you expressed a rational number in p by q form, if q if you in the prime factorization of q, if you have 2s and 5s only, or only 5s or only 2s, then also it's gonna be terminating, right? So now let's take some questions. So here you see, which of the following has non-terminating, repeating, decimal expansion? Non-terminating and repeating, right? So if you have non-terminating, also non-repeating, then it's gonna be irrational, right? If you have non-terminating but recurring or repeating, then it's gonna be rational, right? So here you see, we need non-terminating but repeating. We don't need non-terminating, non-repeating. We need non-terminating but repeating. Okay, so that must be rational. So first two options are irrational, so straight away we can cancel these two. So we have two options, these two. Now here you see the last option, 13 by 125 can be written as 5 to the power 3, right? So here we have only 5s, so that means it is terminating. So we don't need terminating number. Here we are asked to find the non-terminating and repeating. So another irrational number is 1 by 7. Here we have other than 2 and 5, we have another number, that is 7. So that's why this number is, this a decimal expansion of this number 1 by 7, it's gonna be non-terminating and repeating. So hope you have understood the logic behind it. So it was asked in 2015, right? HSLC exam 2015. So now let's go to next question. Here, which of the following is non-terminating, repeating? Again, same type of questions. So here you see its denominator gonna be 5 to the power 4, right? So that's why it is terminating. We don't need non-terminating, it is terminating. So here you see 80, 7 by 80 can be written as 2 to the power 4 into 5, right? 2 to the power 4 into 5, right? Then it is in this form, 2 to the power n into 5 to the power m. So that's why it is also terminating, right? So here you see 3 by 8, it is 2 to the power 3. So we have only 2 to the power 3. So that's why it is also terminating. So let me check its denominator, 455. So 5 9 is 45, 5 1 is 5. So again 7 1 is 7, 7 3 is 21. So other than 2s and 5s, so we have 7 and 13. So that is why it's gonna be non-terminating but repeating. So that's why C is the correct answer. C is the correct option. So now next we have the number of decimal places after which rational number will terminate. This rational number will terminate. Now you see, if you have a rational number 43 by 2 to the power 4 into 5 to the power 3, first check that is numerator and denominator both can be cancelled by any factors, by any 2 and 5. First check that one. Okay, so if not, then you see your answer will be the powers, the which is the greater power on 2, it may be on 2 or 5. We have two powers, that is 4 and 3. So which one is greater? 4 is greater. So that's going to be the answer. Okay, you don't need to think too much, right? Suppose you have a number, suppose let me give you 26 by 2 to the power 2 and 5 to the power 3, or you can say suppose 2 to the power okay, let me take another example, not 26. Suppose you have 52 and you have 2 to the power 4 and 5 to the power 3, right? So now you see, in this case 2 can cancel, 2 to the power 4 can cancel, can be cancelled by 2, and this can be cancelled by 2 as well, to the 4 2 6, that is right. Now this is again, it can be cancelled, 2 to the power 2, and here you will get 13. So from this stage you cannot cancel more, right? 13 by 2 to the power 2 into 5 to the power 3. So here you see we have got the powers 2 and 3. So which one is the greater power? 3. So in this case this will terminate after 3 decimal places. That means after the decimal there will be 3 digits, then it will terminate. So hope you have understood this. Now let's go to next question. So it was asked in 17, HSLC 17, right? HSLC 2017. So now let's go to next question. So here you see same type of questions. So if you express the denominator in this form, 2 to the power n into 5 to the power m, so here you will get that 625, that's equal to 5 to the power 4. So there is no 2's, right? So here you can, that means you can consider 2 to the power 0. So here power is 4, so that's going to be answer should be 4. And here you see, because the numerator is not divisible by 5 as well, so 5 to the power 4 will be the answer. So hope this is clear to you. So it was asked in HSLC 2018. Next important thing is LCM into HCF is equal to product of the two numbers. Suppose you have two numbers A and B, their LCM and HCF respectively are suppose L and H, then A into B must be equal to L into H. This is the logic, right? So here LCM of 91 and 26 is given this, and HCF is we need to find the HCF, right? So simply what you're going to do, just use this logic, right? LCM into HCF, LCM into HCF is equal to product of the two numbers. The two numbers are 91 and 26. So that's why in order to get the HCF, you have to divide this product 91 into 26 by the LCM, right? So what is the LCM here? 91 into 26 by LCM is 182, right? 182, sorry, right? So 91 divides 182, that's going to be 2 times 2 divides 26, that's going to be 13. So answer is 13, right? Option A. That means if you have the two numbers, then take the product of the two numbers, product of two numbers. If you need LCM, divided by HCF, and if you need HCF, divide this product of the two numbers by the LCM, right? then divide it by LCM. So that is the logic. So hope you have understood this. Now let me tell you in which year it was asked. So it was asked in 16, HSLC 2016. Okay, so here you see this is next question number 10. Here it is given, but ignore the question number. Which of the following is an irrational number? So it was asked in 2020. Okay, so there are four options. First one is 0.14282857, 142857, again 142857, and so on, right? Next one is, this is option A. Next one is option 22/7, and next one is pi. Next one is √4/11. So here it is asked which one is irrational. Now you see pi is irrational, remember that. Okay, so you may think that 22/7 is the value of pi, then why it is irrational? How pi can be irrational? Now you see, pi is not exactly equal to 22/7. It is approximately equal to 22/7. Okay, it is always a irrational number. So that is why here our correct option is pi only. So our answer, that's going to be pi. So it was asked in 2020, right? This is 2020, HSLC 2020. So now let me clean this. So here you see next question, HCF of 135 and 225. HCF is given. We need to find the HCF. Two numbers are given. HCF we need to find. So if you have two numbers, 135 and 225, just divide the greater number by the smaller number. So that's going to be one time only, right? So here it's going to be 0, and that's going to be 9. Then divide this divisor by the numerator, 135. So 2 times cannot be given, so just give 1, right? Then you will get 90 here. Then again you are getting 45. Then again divide this 90 by 45. So you have to continue this process unless and until you get 0 remainder, right? So 45, 2 times of 45 is 90, so it's going to be 0, right? So first what we have done, so there were two numbers, 135 and 225. So 225 is greater, divide the greater number by the smaller number. So if you get a remainder which is not equal to 0, then take that remainder and divide the divisor, that means smaller number by which you have divided the greater number, right? Again, if you get again remainder is not equal to 0, then divide this the first remainder by this second remainder. Okay, and if you continue this process until and unless you get remainder equal to 0. So the last step where you have got remainder 0, okay, at that step the divisor was 45, so HCF should be 45. So 45 is the answer. There were two options. First one was of this question, first one was 30375, next one was 945, and next one was 45. So 45, C is the correct answer, right? C. So it was asked in 22, HSLC 22, right? Now next one, here you can see a bell rings at every 18 seconds and another bell rings at 60 seconds. Okay, let me clean this first. Okay, let me clean these things first, then we're gonna read the question, right? So here you see there is a bell who is first bell rings after every 18 seconds and next bell ring after every 60 seconds. These two bells will ring simultaneously again after there are four options. What are those? 30 second, first one is 30 second, next one is 60 second, okay, then C is 90 seconds, then D is 180 seconds. Now remember this case. If you start two things simultaneously, so you have two bells, first one, this is the second one, so they have started at the same time and they start ringing after a regular interval, but in both in these two cases the interval is different, 18 and 16. So if you continue, if these two continue ringing, then the time, that means after how many seconds they will ring together again. To find it, you have to take the LCM of these two intervals. Okay, so what will be the LCM of 16 and 18? So 18 is LCM of 18, sorry, not 18, 18 and 16. So 18 is equal to nothing but 2 into 3 into 3, right? And 60, 2 into 3 into 2 into 2 into 3 into 5, right? So what will be the LCM? So we have 2's here, also 2, so take the maximum, 2 into 2, 3, 3. So we're gonna take this group, 3 into 3, then into 5, 4, 9, 5, 4 into 9 into 5, 5 4 is 20, that's gonna be 180, right? So our correct option is 180 seconds. That's how we can solve. So hope you have understood and hope you have enjoyed this video. If you have enjoyed this video, then please share with your friends and subscribe the channel if you are new to my channel. Also hit the bell icon so that you get notified when new video will be uploaded, and see you in the next video. Thank you.